Let's minimize this. Okay, so the first thing that we're going to talk about tonight is debugging. Developers spend way more time debugging code than writing it. It's absolutely true. So I spend a lot of time debugging. It's almost impossible to write out a piece of code and not miss any gaps in logic and also not make any typos. You know, it's just part of the process, and it refines what you're doing. So what we're going to talk about tonight is some debugging techniques to help you all figure out how to respond to something not working in your code, or maybe a result that you didn't plan on getting when you're going through the workshops. So the first thing that you can do when you get an error is to look through what's called a stack trace. A stack trace is basically just a list of where the error occurred, and it does it in layers from the most specific to the least specific. That's a overly simple way of putting it. But so if you look at line 5 there, right? You see, if everybody can look at the gray numbers beside that that red only odds return a number, so that threw an error. And if you look at the lines there, you can see line 5, right? At only odds, HTTP localhost 7357 only odds dot JS 11 7. So that first number 11, that's going to be the line that the error occurred on. That's the line that caused something to throw an error, to halt the execution of the code and say, wait, something's wrong. It started at line 11. So this is really helpful, because when I am coding, I really want to know where that error came from. What is the problem? Where can I start investigating? So it gives us a place to start looking for what is wrong. It points the magnifying glass on a specific line. This line may not always be accurate, but it's often a good place to start. It's the place that, like I said, where the code said, you know what, stop execution, halt everything, something's wrong here. The actual problem might be somewhere else before that line. It might be that this line is, this point in code is just the point where the collision happened. But the stack trace is a great place to start. And one of the best things that you can do for unfamiliar errors is Googling them. Google's really great on finding other people who may have had the same problem as you. So there's a couple of different basic error types. These are the types of errors that you might see. There's syntax errors, which means that there's been a misspelling, a typo, syntactical error. So like one of the most common things for me is just going through, punching out code. Maybe I have a variable called like num check, right? And I am just going through and I accidentally write in number check, right? That's going to throw an error, and it's just basically a typo, or it's maybe when you're assigning variables, you write a plus equals instead of just a regular equal sign. These are things that are problems with the actual syntax, the actual writing, the way that the code is constructed. So good things to do when you see something like this. First thing is like, make sure that all of your braces, brackets, parentheses, anything that has an opening and a closing set of characters, make sure that everything is open and closed. Make sure that commas, semicolons, arrows are all properly used. And then the second type of error is reference errors. So it'll say you're trying to use something that doesn't exist. So a good example, right? Like, let's say that I have a chunk of code and I, for whatever reason, start trying to use a variable that I've never used, right? Like suddenly I just say, yeah, what is the value of pizza slice? The code, the execution will say, wait a minute, there's no such thing as pizza slice. This variable doesn't exist. So that'll throw an error for you. Does anybody have any questions about those two types of errors or debugging in general? Okay, cool. So the next thing we're going to talk about is conditional statements. Conditional statements are great. It allows you to manage what's called the flow of control in your program. What that means is it's kind of like a fork in the road, right? You can have different paths that your code can take based on conditions, based on the certain state, the certain value or condition of some part of your code. So a lot of times they depend on Booleans, right? Those values that are either true or false. And what you can do here, if you look to your right, you use these if-else statements, and you use those brackets, those curly braces, to segment chunks of code to execute either only if something is true or otherwise. And we'll show some more examples of the way that you can set that up in just a second. But conditional statements control the logic and flow in our programs. You can imagine a conditional statement as like a fork in the road. You can either go through one chunk of code or you can go through another. To write conditional statement, we use the if and else keywords. If this, otherwise do this. If this is true, or if this is, yeah, I guess it's always true. If this is true of the program right now, execute this specific set of code. Otherwise, execute this specific set of code. So if, else, and more. If, else, we say if, and then we use those parentheses. And within those parentheses, we put in some sort of statement that coerces to either true or false. If it's true, then whatever is between the curly braces corresponding to the if statement will execute. So in this case, right, we say if 9 is greater than 8. 9 is greater than 8, so that statement coerces, changes to true. And because it's true, console.log, this is true, executes. In that case, console.log, this is false, never executes, right? That's just skipped over. So we have here some illustrations on it, right? 9 is greater than 8, if true, and it takes you to this, it flows you into this chunk, this code that logs out, this is true. We have this fork in the road, right? We have this other case, if it's not true, else flow into console.log, this is false. We have a third option here besides if and else, which is else if. So it's like providing a backup. It's like providing an additional case, an additional condition that you can attach code to. So in this case, I have a variable num. If num is greater than 8, and here are our options. We have path 1, console log num is greater than 8. If it's true, if num is greater than 8, do this chunk of code, console.log num is greater than 8. If it's not true, console.log check to see whether or not num is greater than 6. If that's true, console log out num is greater than 6 and num is less than 8. And if num is not greater than 6, if num is not greater than 8 and then num is not greater than 6, print out console.log num is less than or equal to 6, right? So you provide like one extra fork in the road. You do the first check, num is greater than 8. That's not true. Cool. Let me provide another condition that I can check off. Is num greater than 6? If it is, now I can console log out another option. If not, move down to that else block of code. So here's if and else, which is two options, either true or execute if it's not true. And then we have if else, else if, right? If, else if, and else. We have some more options there. The terminology here is can be a little confusing because it's a lot of the same words. Does anybody have any questions over this? Over conditional statements? Okay. Moving on to comparison operators. Comparison operators take this idea that a thing is a condition, right? Like a some sort of statement, like num is greater than 8, that can coerce to true. And what it does is it combines statements like that, and it says either both one or more of those statements have to be true in order for this whole thing to be true, or only one of them has to be true for this whole thing to be true. We'll get into the examples and it'll make more sense. So we have this triple equals operator. What this does is it checks if two values are exactly equal, right? Is the number 3 equal to the number 3? Is the string hello equal to the string hello, right? In this case, like if I had a string that was 3, was the character 3, and a number 3, they're not the same thing. One is a character, one is a word, the other is a number, right? So they, using the triple equals operator, they would not be exactly equal. They're not the exact same value. The not triple equals operator means that these two values are not exactly equal. The less than operator compares, right, whether or not the thing on the left is less than the thing on the right. Less than or equals to, greater than. So these are the comparison operators, right? And they're gonna lead us into that part that I was talking about before about combining sets of comparisons. Booleans, right? There's this idea of truthiness. So we have this idea that in JavaScript, things can coerce into other things, right? So the statement 9 is greater than 8, right? That's a statement. But it coerces when you're executing the code. It changes into a Boolean. The code says, okay, run this comparison. 9 is greater than 8. Change that thing into a Boolean. Change it into true. The same thing can be done with actual values, with actual what are called literals, with actual values in JavaScript. In this case, we have a string, and the value is I am a string. And what we're telling you here is that if I put this Boolean and then inside of it put I am a string, that will change the same way that 9 is greater than 8 will into true. It's called type coercion, but the quick way of looking at this is that it takes this value, it takes I am a string, and it changes it into either true or false. And in this case, it's true. The same thing can be done with any non-zero number. Any non-zero number, if I put it in here, it will change it to true. The same thing with an array. If I say, okay, I'm going to take an array and I'm going to place it into this Boolean parentheses, this Boolean constructor is what this thing's called. But if I try to make this thing into a Boolean, it will come out as true. Arrays are truthy. Arrays will coerce to truth. Same thing, objects. Objects are truthy. Objects coerce to true. Objects are truthy. So if I console log all these out, right, each one of them is true. Conversely, there are a specific set of values that will coerce to false when we try to make them Booleans. These are called falsy values. Empty strings, strings with no characters in them, strings that if I put whatever the string is dot length would give me 0, those will coerce to false. 0, null, undefined. And then this thing called non, which means that whatever your value is not a number. A lot of times this is a result of trying to coerce something that is not a number into a number. We really won't get into that in this course, but just know that non also coerces into false. So if I console log all these out, it'll be false. Oh, the Boolean value false also coerces to false. So all of these are false. Any questions about truthiness, about true values versus falsy values? The thing to kind of take away here is that like there's a specific set of falsy values, of values that will coerce to false. All other values will coerce to true. All other values are truthy values. Okay. Then we have the bang operator. This exclamation point also coerces a value, but it does it to, it makes that value the opposite of its truthiness. It's also referred to as a not operator. So here we have console log not true. So the opposite of true is false. So this will log out false. Then we have not ABC. ABC, as we know, is a truthy value. So if we try to coerce it into a Boolean, it will be true. But with that not operator there, it's going to change it into the opposite of its truthiness. It's going to change it to false. So this will also log out false. Then we have not 100, right? 100 is also a truthy value. And with the not, it'll change over to falsy. Then we have an array. Array is also truthy. It'll change over to false. Same thing with object. Object is truthy, so this will become false. And printing all these out, it'll be false, 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 false. The not operator, like I said, changes a value. It coerces a value into a Boolean, but it's the Boolean value that's opposite of its truthiness. The double bang operator, the not, can explicitly coerce a value to a Boolean value that reflects its truthiness. It's like flipping it to its opposite and then flipping it to its opposite, right? So in this case, not true will coerce it to false and then back to true. Not ABC will coerce it to false and then true. Not 100. 100 is a truthy value, and so this will change it to true. Not array will change it to true. Not object will change it to true. This is an alternative to writing that Boolean parentheses syntax. This is a little bit cleaner. I think that it's a little bit faster too. It takes up a little bit less memory. But so all of these, because you're using the not will coerce true. If I had not 0, right, that would coerce to false. It would coerce to 0's opposite, which is true, and then coerce that to false. Any questions on these? Okay, so we have these not operators, these bang operators that can take a value and directly coerce it to a Boolean. We also have the comparison operators, which can compare two values and change them into a Boolean, right? Just like 9 is greater than 8 coerces to true. We can combine these things. We can combine multiple either values or multiple coercions, multiple statements into larger sets of either truthiness or falsiness. The logical operators. We have the double ampersand, right? That's no, the double and symbol. So and returns either the first falsy value or the last falsy value. And then more commonly used, it's a way to test whether or not two things are true. If both things are true, then the whole thing is true. So it does two things, right? In this case, returned value 1 is going to find the first falsy value or the last truthy value. The first truthy value is 10, right? The second truthy value is apples. There are no more truthy values, right? Really what happens here is that it goes from 10, it checks off as truthy, goes to apples, checks off truthy, and then hits that first falsy value, the 0, and it returns that. And is like a way, is like either all of these things are true and I'm going to give you the last value, or one of them's false and I'm going to give you that first false value. So if I log out what this is, it's going to be 0. here we have lucky, we have the string number. Both of those are true. And then we have 7, and 7 is also true. So we go true, true, true. Return the value 7. So now return value 2 is equal to 7. This thing like really threw me for a loop the first time I encountered it. Does anybody have any questions? Do you guys want me to do some demos on this? Maybe I'll do some demos after we finish up the slides. So we also have the OR operator. The OR returns either the first truthy value or the last value if all are falsy. And then more commonly used, it's used to say, okay, I have a set of comparisons. I have a set of things that are going to coerce either true or false. If any one of them is true, the whole thing's true. But in this case, we have return value, null, undefined, happy, pumpkin. So null and undefined, those are falsy. So it goes false, false, and then it hits that happy, and it says, wait, this is a truthy value. Return that immediately, right? So now return value is happy. Then we have return value 2. So it says false, okay? That's a falsy value. Null, falsy value. 10 is less than 0. So here's a conditional operator. Here's like a statement, right? Or an expression. 10 is not less than 0, so that coerces to false, which is a falsy value. And then non is also a falsy value. So all of them are falsy. So we take the last value, which is non. So now returned value 2 is equal to non. And we log them both out. We get happy and non. Cool. Any questions on these before we start jumping into some of the demos?
Question for you.
Yeah.
So far it all makes sense, the context of with the examples you explained right here. But what would the functionality of that be in, say, a real world situation where you're programming for a website or something like that?
So there's 2 ways that you use this practically, right? So there's one way, which is to say like, okay, cool. So is this showing the screen share?
Yeah, I can see that.
Okay, cool. So you have like, let's say like, you could say like in your code, if 9 is greater than 8 and 10 is greater than like 3, do this chunk of code, right? So I might set up like some sort of bit of code up at the top to say like, let's call these different variables. Let's say like A and B and then X and Y, right? And I say like, okay, X is equal to some like 10 plus 1 plus 5, some sort of data that I get from another place or some sort of data that I'm building up and calculating, I'm going to store in this X, right? And then maybe I do the same thing with Y, right? In this case, I'll just say 1, let Y. And then I do the same thing with A. Maybe that ends up being 4, and let B is equal to 2, right? So like somewhere up above in my code, I've calculated all of these out, and I want to make checks, multiple checks, where I say, I need both A to be greater than B and X to be greater than Y in order to run like this specific. Why are you bumping me up? Oh, it's because, right? Does this make sense?
Yeah, this makes tons of sense.
Yeah, yeah. And like you don't need an else statement with an if. You need an if in order to do an else, but you can just run an if statement, right? So like okay, let's say that like for all intents and purposes, A and B or A and X need to be greater than X and Y in order for like whatever down here to happen. One thing I could do is just say like figure out what the values are and set A to like some sort of value, default value, right? Set A and X to like default values, right? So this prevents me from having some sort of error, like some sort of explosion down here. I can like set up some sort of check and then have them go. Yeah, so that's one way. The other thing comes mostly from like objects that you are what they call consuming. You're receiving them from another place. So let's check out an object called like I
Yes,
think
please.
yeah. So we got an object. So like let's call it cat, right? Um, shoot. So we'll talk more about objects in our next lesson. All I want you to know about here is that like cats have these things called properties, right? Like objects have like let's say it's a name. This cat has a name called John, right? So I can say console log out cat dot name, and this thing exists inside of here. If I don't have this, this will be undefined, right? If I do have it, it'll hold a value. And like a lot of times, you'll request information from somewhere else, and it'll come in and it'll look like this. It'll be in object form, and I'll write code that will say I need this cat to have a name. My code depends on this cat having a name. It'll blow up if it doesn't have a name. So kind of the same way that I'm assigning default values, I can say, like, let's say I want a new variable that I'm going to play around with later on in my code called cat name, and it's going to be equal to cat dot name, right? If I want to make sure, or if I want to set a default value to cat name in case this is undefined, there's a couple of ways I can do it. I can say cat name or this or like cat or like no name, right? So now what'll happen here is if this is undefined, this will come in here. This will say, okay, this is false. And then now I provide it with a default truthy value. So now I give it a truthy value in case this is not provided to me or is missing in some way. Value, what's the value of cat name? Value, no name, right? This is false. It's that or logical operator. This is true. If I do give cat a name, cat name will be John. Right?
Okay, that makes sense.
Yeah, yeah. It's just like these things a lot of times are just used to cover your bases. These like getting a value out of them. That's how I use them, is to like cover my bases in case I get something that's going to make my code explode. The putting them together in like saying like this format, if cat name, or like, I don't know, like default value is given, right? Like this is just flow of control stuff. This is an extra check to flow the code towards a certain path, to make it do a certain set of stuff.
Okay, that makes sense.
Yeah, cool. Any other questions?
Thank you.
Yeah, no problem. Any other questions or anything else you guys want me to demo? I'll give you guys one more quick example of the reference error. So like, let's say I take off that cat, and now I'm trying to reference this variable. That's not fair. Let's do pizza slice. I think that's what I did before. So I'm just trying to log out this pizza slice thing. This isn't ever defined. It throws me this reference error, and it says, hey, the place that this was thrown was on line 5. 1, 2, 3, 4, 5. So I can come here, it's this first number right here, and I can come to it and say, oh, okay, this pizza slice is, something's wrong with that. I can also, the other one that you'll see is like, maybe like, I was trying to think of like a syntax error. So like if I get rid of that and I say print out cat, it'll throw me a syntax error, and it's like unexpected identifier. And it'll show me at console log cat. You can see here that it's saying, hey, it's being thrown at line 5, right? But the problem's at line 4. This, so like this helps me because I'm like, okay, this is where it blew up, but let me look up here and figure out what the deal is. A lot of times unexpected identifier, that means that you're missing a curly brace, or like maybe you didn't include a comma or something. A lot of times it has something to do with like that type of stuff, as opposed to like a name or like a variable. Cool.